Hello everyone, this is my third video for the channel. Here we are going to cover name reactions alphabetically. It will be a series of name reactions, so this video is part A of the series. Just keep that in mind that name reactions are basically based on the name of scientists, but some of the name reactions are also based on the name of products. In this video, we will cover two types of condensation reactions. First one is Aldol condensation reaction, and the second one is cross Aldol condensation reaction. We will start with the basic and then we'll cover definitions, examples, the summary part, and at last, topic related questions. So first of all, we will start with the basic part, that is condensation reaction. It is a reaction in which two or more molecules of the same or different kind combine to form a condensed product with or without the elimination of a smaller molecule like water, ammonia, ethanol, etc. It is basically of two types. One is self-condensation, which is a reaction between molecules of the same compound, like two same aldehydes, like two same ketones. Second is cross-condensation, which is a reaction between molecules of different compounds. So starting with our first name reaction, that is Aldol condensation. It is a self-condensation reaction which requires aldehyde or ketones having at least one alpha hydrogen atom. In this reaction, aldehydes or ketones of the same variety having at least one alpha hydrogen atom react in the presence of dilute alkali, that is a dilute base, which work like a catalyst, forming beta hydroxyaldehyde, that is aldol, or beta hydroxyketone, that is ketol, respectively. Beta hydroxyaldehyde is known as aldol because it contains both the groups, that is aldehyde group as well as alcoholic group. And beta hydroxyketone is known as ketol because it contains ketonic group as well as alcoholic group. These products formed easily undergo dehydration reaction when these are heated or reacted with dilute acid like dilute HCl to form the unsaturated carbonyl compounds, which are quite stable due to the conjugation property. For aldol condensation reaction, the basic requirement is the presence of alpha hydrogen atom in the aldehyde or ketone. Alpha hydrogen is the hydrogen atom attached to the carbon atom which is adjacent to the functional group. As we can see in the first picture, which is an example of aldehyde, the functional group is CHO. The carbon atom attached to it is known as alpha carbon, and the hydrogen atoms attached to it are called alpha hydrogens. In the second picture, which is an example of ketone, there are 2 alpha carbons and 6 alpha hydrogen atoms. For our first example of aldol condensation reaction, we are going to take 2 same aldehyde molecules containing alpha hydrogen atom. In this case, we are going to take example of reaction between 2 ethynyl molecules, which is also known as acetaldehyde, reacting in the presence of sodium hydroxide, that is NaOH, for forming the aldol product. For our first example, we are having 2 ethynyl molecules. In the first molecule, there will be dissociation of bond between carbon and oxygen. Carbon will lose its shared pair of electron and will gain a positive charge, whereas oxygen will gain that electron having a negative charge. The alpha hydrogen from the second ethynyl molecule will lose the shared pair of electron towards carbon atom and will become positively charged and then migrate to the negatively charged oxygen atom of the first ethynyl molecule. The positively and negatively charged carbon atoms will form a bond, giving rise to aldol as product. Aldol, when heated, will lose a water molecule, forming alpha-beta unsaturated product. For our second example of aldol condensation reaction, we are going to take 2 molecules of the same ketone containing alpha hydrogen atom. In this case, we are going to take example of reaction between 2 propanone molecules, which is also known as acetone, reacting in the presence of dilute alkali In this case, we are going to take sodium hydroxide for forming the condensation product, which is known as ketol, containing ketone and alcoholic functional group. In this example, we are reacting two molecules of propane-2-one, that is acetone, in the presence of dilute sodium hydroxide. Similar to our first example, alpha hydrogen atom will migrate to negatively charged oxygen atom of the first molecule after the bond dissociation, and then the carbon atoms with positive and negative charge will combine to form ketol as condensation product. The condensation product on heating will lose its water molecule, forming alpha beta unsaturated product. Our second named reaction is cross-aldol condensation reaction. It is a cross-condensation reaction in which two different compounds containing alpha hydrogen will react in the presence of alkali, forming the condensation product. We can take two different aldehydes for the reaction, or two different ketones, or we can take one aldehyde and one ketone as the combination. The basic condition in this case is the presence of alpha hydrogen atom with at least one of the reacting molecule. For our first example of cross-aldol condensation reaction, we are going to take one aldehyde molecule and one ketone molecule. We are going to react ethanol as aldehyde and propanone as ketone in the presence of dilute sodium hydroxide, that is dilute NaOH. In this case, alpha hydrogen atom from ketone will migrate to the oxygen atom of the carbonyl group present in the ethanol molecule, giving rise to condensation product, which will easily lose water molecule, forming alpha beta unsaturated stable product. In this example, we are reacting ethanol and propanone in the presence of dilute NaOH. In this reaction, alpha hydrogen atom from propanone will migrate to oxygen atom of ethanol molecule, forming the condensation product, that is 4-hydroxy pentane 2-one. This condensation product, when reacted in the presence of dilute HCl or any other dilute acid, or when heated, will lose its water molecule, forming alpha beta unsaturated product. For our second example of cross-Aldol condensation reaction, we are going to take two different aldehydes. As multiple products are possible in this case, this example is divided into two parts. In the first part, we are going to take propanol and ethanol and will migrate alpha hydrogen atom of ethanol molecule to the oxygen atom of propanol. After migration of alpha hydrogen, condensation product will be formed, which will easily lose water molecule when it is heated, forming alpha beta unsaturated condensation product. So, as we can see here, in this reaction, our first reactant is propanol and the second reactant is ethanol. So for the first part of this reaction, we are going to migrate alpha hydrogen of ethanol to the oxygen atom of carbonyl group of propanol, forming 3-hydroxypentane-1-ol as aldol product. This product will easily lose out water molecule when heated or when treated with dilute acid like dilute HCl. After losing water, it will form pent-2-ene-1-ol. Now, for part B of this reaction, we are going to take ethanol and propanol again. But this time, the difference will be that we are going to migrate alpha hydrogen of propanol instead of alpha hydrogen of ethanol. So we are going to migrate alpha hydrogen of propanol to oxygen atom of ethanol in this reaction. Because of possibility of formation of multiple products in this case, this reaction is divided into two parts. In first part, we have migrated alpha hydrogen of ethanol, and the second part we are going to migrate alpha hydrogen of propanol. As we can see in this reaction, our first reactant is ethanol and the second one is propanol. In case of propanol, there are total 3 carbon atoms. First carbon atom is of aldehydic functional group, that is of CHO group. The carbon atom next to this CHO functional group is our alpha carbon, and hydrogens attached to this alpha carbon are our alpha hydrogen atoms. So we are going to migrate hydrogen atoms attached to this alpha carbon to the oxygen of ethanol for forming the condensation product. So summarizing all the important points, firstly we require aldehydes or ketones containing alpha hydrogen atom. Second is the presence of alkali. After reaction, aldol or ketol is formed, which readily lose H2O molecule, forming alpha-beta unsaturated stable product. Though ketones form ketol, still the general name aldol will be applied for all the reactions. So here is one question for you all. Why do compounds like benzaldehyde, benzophenone, formaldehyde and trimethyl acetaldehyde does not undergo Aldol condensation reaction? Give your answer in the comment section and we will cover the answer in the next video. Thank you all for watching this video. I hope you would have liked it. So please share it, subscribe to the channel and don't forget to hit the bell icon for getting more updates. Thank you.